Dear students, in last video we have seen about column chromatography as an example of adsorption chromatography techniques. So in this video we are going to see about thin layer chromatography. So just a recap of types of chromatography. We have three types. One is adsorption chromatography, partition chromatography and ion exchange chromatography, right? So here the partition chromatography, it works on the principle distribution between two phases. We have seen already, right? So here the thin layer chromatography is similar to adsorption chromatography, not a partition chromatography, because in partition chromatography it works on distribution coefficient between two phases. We have seen already adsorption chromatography, and example is column chromatography, and this thin layer chromatography is also similar to the column chromatography, but here the only difference is thin plate. Thin layer chromatography, thin plate is used, whereas in column chromatography we are making the column or fixed phase in a cylindrical tube. We are tightly packing without any air gap of active solids. But in case of thin layer chromatography, we are making a thin plate. So it is more or less similar to adsorption chromatography, that is column chromatography, works on adsorption principle. Here also it works on adsorption principle. The same active material is coated on a glass substrate as a thin layer. We have seen different types of active solids like silica gel, alumina, magnesia, carbonates, some kinds of activated charcoals, and different types of activated solids where stationary phase is made. Instead of making a column like packing in a tube, here we are making it as a slurry and we are making as a thin layer. That is the only difference between column chromatography and thin layer chromatography. Now we'll see about thin layer chromatography. Again, thin layer chromatography is an important technique used for identification and separation of mixture as well. So if more than one compound is mixed up in a material together, or while you synthesize more than one product obtained using chromatography, you can separate it out. So as I said earlier, the common factors for all chromatography, thin layer chromatography also consists of two phases. One is mobile phase, which is a liquid, and another one is a stationary phase. So here a stationary phase is solid. The stationary phase, how here it is made? A solid compound is made into slurry, and that slurry is coated on the thin plate like a glass substrate. After drying, you can see a uniform dispersed sample on the glass plate. So, in principle, the component of mixture are partitioned between absorbent, that is a stationary phase, and the solvent phase. Since this is also partition takes place between the stationary phase and mobile phase. Even though it is similar to adsorption chromatography, there also the solid mixture flows due to or with the help of mobile phase, that is eluent which carries the sample. Here also it is the mobile phase. Solvent carries the sample in the thin plate and separates the individual components. So in thin layer chromatography, the individual compound gets separated due to the relative affinity towards stationary phase and a mobile phase. So if you remember, in column chromatography, we have a solid substance as a stationary phase. So in stationary phase, how these bands is separated, it depends upon the relative affinities towards mobile phase and stationary phase. Similarly here, when the affinity is more towards stationary phase, that will move slower. The flow rate is lower for more affinity sample. If the affinity is less towards stationary phase, it will flow faster. So in thin layer chromatography, how this stationary phase is made, how this thin layer is made, usually or generally the thin layer chromatography is made using silica gel or alumina. At instance or first, we have to make the silica gel or the alumina powder into slurry. So to make it a slurry, first this alumina powder or other active solids is finely ground, because to attain the uniform in particle size. This uniformity in size of the active solid makes very efficient in separation. So to make a slurry, we use different types of binder. Say for example, plaster of Paris. So either plaster of Paris or calcium sulfate can be used for making active solid as a slurry. So this binder helps to adhere to the glass substrate. Otherwise, after coating and drying, it will peel off. So the binder here helps to stick the active solid on the glass substrate. So once the slurry is made using silica gel and alumina powder or alumina, or in some case other active solids also, is coated on glass substrate. After coating this glass substrate uniformly on the substrate, it is heated at in a oven for about 30 minutes. Generally 80 degrees is used for drying the silica plate. So in thin layer chromatography, making a thin plate or thin layer TLC plate, or otherwise you can say, is very important, that decides the efficiency of separation of mixture. So here you can see the TLC plate coated with active solid. So here this is the TLC plate for your reference. So it is the rectangular glass slide. This rectangular glass slides for identifying or for collecting blood sample, earlier this plate was used. A similar kind of plate, glass substrate, is used for TLC. So here the glass substrate is coated with the active solid on the surface. So after drying, it looks like this. This is the exact picture of TLC plate. Once TLC plate is ready, the substance or the mixture to be identified or to be separated is made into liquid. So if the substance is a solid also, suitable solvent you have to decide and you have to dissolve it to make a liquid. So once thin plate is ready, what you have to do is a mobile phase. So mobile phase in general, it is a developing liquid which flows through the stationary phase carrying the sample with it. Means it carries the sample along with it on the solid or stationary phase. When it carries the sample, the mixture, different compound in a mixture will have different affinity towards the solid surface or towards the surface of active solid. So generally the interaction between the solids or active solid and the mixture of compound which is in a liquid form will have interaction while moving. If a compound is having higher affinity, then there will be more interaction between the solid phase and the mixture. If the attraction is more, the movement will be less. Therefore, the compound with more affinity towards stationary phase will travel slower. The compound with less affinity towards stationary phase travel faster. So once stationary phase and mobile phase is fixed, then we have to go for plate development. For plate development, we should take a solvent, suitable solvent in a beaker, and we have a sample mixture in liquid form. A drop of solution, that is a sample, is placed at one edge of the plate and we have to mark that in a visible manner, either line or some marker. Once a drop of solution at the one end of the plate is kept. The plate is kept in a beaker where it contains enough solvent. Here the solvent will carry the sample on the surface of the plate. So this, after keeping this plate, a spotted plate in a solvent, that is in a container with the solvent migrates up in a plate with component of mixture at a different rates. This difference in rate is due to the affinity of a sample towards stationary phase. Once a solvent reaches the top of TLC plate, it is removed and dried. So as I said earlier, more polar analyte interact with the stationary phase more and it moves very slowly, whereas a non-polar analyte will interfere with the stationary phase less and the movement will be very fast. So in thin layer chromatography, how this movement can be validated or how it is understood, it is given by the value RF value. Here RF stands for retention factor. So TLC results are generally represented in RF value. Here the formula for RF is distance travelled by a solute. Solute here in the sense the mixture of compound divided by distance travelled by solvent. So this RF value is a relative difference between the distance travelled by solute and distance travelled by a solvent. So here we have indicated A and B. A is by solute and B is solvent. This RF value will give you about the movement of or about the affinity of mixture towards a stationary and which can be separated easily, which can move faster. So after separation, the mixture can be obtained by either by extracting using a solvent or by cutting into different partition. So here the colorless compound also can be identified. So once it moves, if you look through the UV chamber, UV light, it can be visualized by fluorescence. Compound is visualized by fluorescent. Another method is also available to locate the spots, colorless spots. Spraying a detecting agent on the chromatogram. This detecting agent such as sulfuric acid, KMnO4 and iodine solution, we can able to spot the chromatogram, or we can able to spot the sample material. So this is about the thin layer chromatography. Now if you see the application of thin layer chromatography, it is used for a routine analysis of mixture of composition. If you involve in any organic synthesis at any stage or at every stage, you can use thin layer chromatography to identify the completion of reaction or identification of completion of reaction at particular stage. This thin layer chromatography is used qualitatively and quantitative analysis to separate organic compounds. It is also used to identify the best eluting agent for column chromatography. The eluting power, if you know, that can be cross-checked or identified, validated using this thin layer chromatography. Before doing chromatography, column chromatography, you can check the eluting power of a solvent using thin layer chromatography. Then you can use that solvent in a column chromatography for the better performance of column chromatography. And also the purity of sample, purity of compound can be analyzed using thin layer chromatography. When you compare to column chromatography, the major advantage of thin layer chromatography is that if you have a very less compound, say for example, if you have sample in milligrams, even 1 milligram, using that compound you can able to analyze the purity, or you can able to separate using thin layer chromatography. So the analysis can be carried out with the minimum amount of sample in thin layer chromatography. This is the advantage of thin layer chromatography over column chromatography. So this is where thin layer chromatography is helpful for carrying out the organic reaction, or to separate, or to purify. Thank you.